Okay, friends, so we're going to start into the probability part of the course next. So up till this point, with the exception of projects, we've been dealing mostly with statistics. And they're great because, the course is actually called Intro to Prob and Stat. But statistics, as you may have felt a little bit invented, because it actually is. It's a way for human beings to create measures to discuss data that they see. I've been ignoring, until now, the behavior of that data as it comes to you. And that's what I want to get into now. Now that we know how to crunch numbers, let's look at how the numbers come at us. Now, if you've had me in previous classes, we've actually addressed some of this in the past, not to the depth that we're going to get to it in here. And the topic that I want to start with is called probability distributions. Now, it sounds terrible, probability distributions. We've already dealt with the distributions part back when we talked about grouped data, looking at a t-table, for example, where you've got, the values of the statistics that have come at you and the frequencies with which they come at you. And that's going to be extraordinarily closely related to probability distributions as well. The part that makes this probability and not pure statistics was, in the statistics distribution and the frequency distributions, we observed data coming in and kind of kept track of it and then kept track of frequencies as we saw it. With probability distributions, we're going to have these things called random variables. Random variables. Now, why are they called random variables? Well, it's actually one of the most concise names in probability theory. The random part means you don't know what's going to be happening on any given trial. And the variable part just gives you the idea that that thing that's going to be happening has a range of values. Let's look at a simple example. A six-sided die, one of my favorite things to play with in Math 243. When you roll a six-sided die, you don't know exactly what's going to happen on that next roll. All you know is there are 6 possible things that could happen. And on any given roll, one of those 6 things is happening. So you know the limits and all the inclusive values that could happen. This is slightly different than statistics when you're observing a study. Because when you're observing a study, sometimes you don't know exactly what data is coming in. Right now, I'm collecting your guesses on my heights and weights. And there are all kinds of numbers coming in. I have no idea who's going to say what when. I've got some ideas, like nobody's saying I weigh 90 pounds, and nobody's saying I weigh 620 pounds. But still, there's a pretty wide range of values that are coming in. When I roll a 6-sided die, there are 6 things that can happen. 1, 2, 3, 4, 5, or 6. When I roll it, I'm going to roll it right. I just dropped it. We'll count that as a roll. And I just rolled a 1, which means that's the result of my experiment. The random variable I just got was 1. Let's roll it again. I just got a 3. What a probability distribution allows us to do is to organize the results of an experiment, in this case, rolling a single die 1 time. It allows us to organize them into a convenient and total form. Let's take a look.